Okay, an object is thrown upward from a height of 5 feet at an initial velocity of 35 feet per second. Find the maximum height of the object. So again, maximum height, we know that's opposite of the b divided by 2 times a into an xy coordinate. So if I know that that's my go-to formula, I'm just going to make this parabola. Remember, maximum means you're finding the vertex. And I formulate my xy. So x is opposite of b divided by 2 times a. Okay, so I need an equation. It's x second x constant equals y. So remember what y is. It's your maximum of whatever you're finding. Y is your height. So gravity is what's changing our height. Makes it reverse course, and then 35 feet per second. And we have 15 feet here at the beginning. So opposite of b divided by 2 times a. Okay, so opposite of b, negative 35. 2 times negative 16 is negative 32. Then I divide negative 35 by negative 32. 1.09. 1.09 seconds, and then we will be putting 1.09 into the equation for x. Okay, and then that easily finds y. Since y is so low, it's very easy to figure it out. Okay, 34.14. So 34.14 feet is going to be your maximum height. Okay, next problem. Object is thrown upward from a height of 15 feet at an initial velocity of 35 feet per second. Find the object's height at 0.5 seconds. So now I'm finding the feet, so I'm not finding the maximum. I'm trying to find the number of feet at 0.5 seconds. So I'll be making a parabola, but I'll just make it over here. I need to conduct a unit analysis for my feet. Feet in seconds. Seconds is x, feet is y. So we'll be solving for the y. Feet per second. Okay, the feet per second, 35 times x. Now again, you should deduce that gravity is what pulls it up and down, the object, which is negative 16x to the second power. Okay, so prior to 35 feet per second, we had 15 feet, and then 0.5 seconds we put on the other side. So question mark feet. So you have x to the second, x constant equals y. So negative 16, and then 35, and then 15 goes in your constant. Okay, so 0.5 seconds needs to go into the equation for the x, okay? So then we replace both of these with 0.5. So negative 16 times 0.5 to the second power plus 35 times 0.5 plus 15 equals y. Okay, so we substitute that in. At 28.5. So y is feet, so the feet is 28.5. Okay, next problem. An object is thrown upward from a height of 15 feet at an initial velocity of 35 feet per second. After how many seconds will the object be 20 feet in the air? So I'm solving for seconds, so I do a unit analysis with the seconds. And then feet equals y. So the rate of change between the two variables, the feet per second, is 35. At least that's an initial rate of change when you first launch it, but eventually gravity changes that to negative 16x second because it goes up and down. Okay, so we have 15 feet on right there, and then 20 feet on the way down. Okay, so now x to the second, then the x, then the constant equals y. So we have the gravity coefficient, negative 16, then we have 35, and then 15 feet goes in for the constant, then 20 feet goes into the equation, but unfortunately it doesn't go in for x, it goes in for y, because feet is equal to y. Okay, just get your 20, and now we have to solve for x. Now, x is to two different powers, a second and a first, okay? So you have to apply your factoring properties. See, in the last problem, you replace the x, you had the y. Well, y is solo, so you can just plug that in. But now that the variable is not solo, I see it's the second to the first, so we have to apply our factoring properties. Actually, one thing I screwed up on this one, I wasn't thinking. The last one, go back to the last page, okay? As soon as you replace the x's here, you need to put y and then put solo. That means there's one answer and you just substitute it, okay? But this time the x definitely was not solo, so I put the two powers down and I have to apply factoring properties, okay? So there's two answers. So you have to get your 0 there, minus 20 from 15. So you have x second, the x, and the constant equals 0. So you have negative 16, then 35, then 15 minus 20 is negative 5. So there's three terms, so I'd go GCF and the t-table. So I don't have x, I do have the negative. And then 16, 35, and 15. So 5 is your smallest, okay? No 16. Well, the only other place 5 is in 1. And every number's in 1's row, okay? Any integer is divisible by 1. But it's negative 1, so I will go ahead and do it. If it's 1, I just cross it out and don't do it. But dividing by negative 1 changes these to opposite. So that goes from plus to minus, and that goes to positive. Okay, so you can bring your factor of negative 1 over there. Not that it's that important because it doesn't have x. Then 16 times 5 is 80. Okay, so it's positive, so that's got to be a match. And it's supposed to add to negative 35. So 80 divided by 1 is 80. So you add those, negative 81, that's too wide. Okay, 80 divided by 2 is 40. That's negative 42, that's too wide, okay? 3 is a decimal, 4 and 20. Now if I add negative 4 to negative 20, now it is too low, okay? It's too wide of a gap, or it's too narrow now, because it goes from being too wide, it skips over and becomes too narrow. So that is the quadratic formula. So x equals opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of b is positive 35, b to the second, so it'd be negative 35 to the second, and then 4a is 16, c is 5, then a is 16. Okay, so you got 35, 2 times 16 is 32, then I make my square root, and I substitute that into the equation, so negative 35 to the second, minus 4, 16, and 5. I got 905. So now I find the square root of 905, and that ends up being 30.08. So 35 plus 35.08, or excuse me, 35 plus 30.08, click equals, divide by 32, 2.03. I take 35 minus 30.08, click equals, divide by 32, 0.15. Now you want to put the 2.03, because we're interested on the way back down. Because see, it does cross 20 feet on the way up, which is why you get 0.15 seconds. Then on the way back down 20 feet, it goes with 2.03 seconds. Okay. Put question mark seconds there. We have just found that it's 2.03. Okay, next problem. A surfboard shop sells 45 surfboards in a month when it charges $500 per surfboard. For each $20 decrease in price, the store sells 5 more surfboards for the month. How can the shop maximize monthly revenue? So again, maximum revenue. So we know maximum anything's opposite of B divided by 2 times A at this juncture. So I just draw that big parabola with the vertex label. And I set up the XY coordinate where I find both of them. Find X first using the opposite of B divided by 2 times A. Okay, so maximum revenue. So Y is, this time wouldn't be height, it'd be revenue. So there's going to be an X second, an X, and a constant. We know that. But to get revenue, you need to take 2 quantities. One quantity represents the price you're charging for the items, and the other one represents the number of items. So to know how to fill that out correctly, you're going to want to make your table with money and items. So the money starts at $500 and the items start at $45. Okay. Then, what's happened to the money? $20 decrease, so minus 20. And then 5 more surfboards, so plus 5. So 500 minus 20 is 480. And then 5 plus 45 is 50. Then I minus 20 again, it's 460. And then plus 5, it's 55. Now, if you want, you don't have to do this, but you can take the money times the items, 500 times 45, 22,500. So that's your revenue from the start. Now you're changing it, so it'd be 480 times 50, 24,000. So as you can see, my revenue went up. And then 460 times 55, 25,300, and the revenue went up again. So when does it stop going up? That's the question. That's what this will figure out for us. So the money, you start at 500, and the items, you start at 45. Then we're subtracting 20 from the money amount, but we're doing that over and over. I don't know how many times I'm subtracting 20. That's unknown, so that's why 20 has to be multiplied by X. And then plus 5X. Now you execute the FOIL method. Because you have to get from... So I take 500 times 45. And then 500 times 5X. And then negative 20x times 45. And then negative 20x times 5x. So 500 times 45 is 22,500. 500 times 5x is 2,500x. And then negative 90x. Then x to the second, and that's going to be negative 100. So negative 100 is my x to the second. That's your A. Now you combine your x's. 2,500 plus negative 90, that's going to be, or excuse me, I'm wrong. It's not negative 90, it's negative 900. That's my fault. So 2,500 plus negative 900, and that's going to be 1,600. That's your B. Then 22,500. Now that's my C, but I don't really use C as a variable. So the opposite of the B is negative 1,600. Then 2 times negative 100 is negative 200. Then I divide these and it's 8. So what that represents is from the initial, you'd have to change the price 8 times. 8 changes. And then to find the Y, the money amount, I would replace the X's with 8. Okay, now find what you get here. So negative 100, then 8 to the second, plus 1,600, then 8, plus 22,500, 28,900. So So that's your maximum revenue. Okay, last problem. This one's kind of a weird one. An object is dropped off the roof of an apartment building that's 240 feet tall. How long will it take the object to hit the ground? So seconds, okay? So you got seconds and feet, okay? X is seconds, Y is feet, so feet per second. Now you notice how we don't have a feet per second, okay? That's because there's no acceleration rate to it, okay? So feet per second, you put NA, because you see, this goes just straight down. It doesn't go up and down, they just drop it, okay? So straight down, and gravity still takes it straight down. Gravity, negative 16x a second. So instead of making a U, you're just taking the object from its initial point and dropping it straight down, okay? All you have to do is label the initial height, 240 feet, and then we don't have another height, so I assume that to be 0 feet. But I formulate it the same way. We still need the negative 16x to the second, and then negative 16 fills the x to the second. Now the feet per second, that's 0, so you can get rid of that, okay? Actually, just put 0 there. Just put 0. Now you start at 240 feet, okay? And then 0 feet, I'm going to put question mark with the seconds, because that's what you're solving for, seconds equals. So 0 feet goes into the equation, and it would go into the equation for y. So 0 replaces the y. Okay, so I have x to the second only this time. I don't have x to the first, so that only is good. That means I don't have to factor. I can use linear properties to solve it. Now there's two answers. Linear properties means you look on the side of the x second times second power plus. So circle the times, and you take out your plus with minus. So it's going to be negative 240. Now you divide both sides by negative 16. So negative 240 divided by negative 16 is going to be 15. And then I find the square root of 15. Now it's an irrational square root, but it still has a value nonetheless. So the square root of 15, what number times itself is 15? Well, there's no rational number times itself that's 15. So it'd be 3.87. So 3.87 positive, 3.87 negative, and the positive then would be the legit answer, okay? So at 0 feet, it's taken 3.87 seconds to get from 240 feet to 0 feet. So again, gravity's still pulling that down,